Hi everyone, my name is Sheikh Hussain. I have been teaching chemistry for the past 22 years for IIT JEE, NEET and state board exams. In this video series, I am going to explain all important questions for intermediate for the students who are studying in Andhra and Telangana. I will provide short, simple and to the point explanation for all the answers to help you score full marks. The study material I am going to use in this video series is carefully prepared by my friend Santosh Kumar Reddy, PGT Chemistry. For regular updates, do follow my channel and join our WhatsApp group using link in the description. Let's get started. Hi everyone, welcome to my channel. In this video series, we are going to discuss all important questions in a short and simple manner for both the students who are studying in Andhra and Telangana. So in this video, particularly, we are going to discuss chlorine preparation and its properties. And it's one of the very important, most important question and repeatedly asking in the public exam. But here in the chlorine preparation, there are two parts actually. That is the laboratory method, preparation of chlorine in laboratory method or decons method, and second one is industrial method, that is Nelson cell method or electrolytic method. That Nelson cell method we will discuss separately, and the chemical reactions of chlorine, all the chemical reactions, important chemical reactions we discuss in this video itself, and the preparation of chlorine by industrial method we will discuss in another video, right? So here see the question, how is chlorine prepared in the laboratory or decons method? How does it react with the following: cold dilute NaOH, hot concentrated NaOH, excess of ammonia, ammonia with excess of chlorine, with Slaker lime, that is calcium hydroxide, and acidified ferrous sulfate, hydrogen sulfide and sodium thiosulfate. Okay, we'll start the answer. First, let's see how chlorine is prepared in laboratory. Heating manganese dioxide with concentrated hydrochloric acid gives chlorine. Heating manganese dioxide MnO2 with concentrated hydrochloric acid HCl gives chlorine, right? Don't try to by heart the reactions, try to understand the reaction. Here all the reactions I will give you some short tips and tricks so that you can learn the reaction very easily. And one more thing is, while listening to my class, you feel that you understood the reaction, but after 1 or 2 days you will forget. For that, what you should do, whenever you watch the video, whenever you listen to my video and write on a paper, take a notes of it, practice on the same day. Without practicing, you cannot get all these reactions. Okay, reactions, for reactions you should practice. Only the practice is the magic. It makes a magic. This reaction I will explain in a very simple manner. So whenever in any reaction you see hydrogen one side and oxygen other side, you will get water. That's all. So how many water molecules will be formed? That is equal to number of oxygen molecules. Here 2 oxygen molecules are there, so 2 water molecules will get. So hydrogens will be 4. Otherwise you can remember like this: half of the number of hydrogen atoms. Here 4 hydrogen atoms are there, so 2 water molecules will be formed. If there are 8 water molecules, if there are 8 hydrogen atoms, then 4 water molecules will be formed. So the process will be like this, and there are some exceptions and that we'll discuss when it comes. So here 4 hydrogens, 2 oxygens combined together and 2 water molecules will be formed. That means hydrogens and oxygens are over. Next, what are left? Manganese and chlorine. How many chlorines are there? 4 chlorines are there here. This 4 is common for all. Out of 4 chlorines, 2 chlorines combine with manganese. So MnCl2, manganese chloride, and the remaining 2 chlorines will be as a Cl2 gas, chlorine gas. This is how chlorine gas will be prepared by reacting manganese dioxide with hydrochloric acid. Next, come to decons method. This is asked as a 2 marks question as well, and it is an important question. That means decons method is separately asking for 2 marks, very short answer question, and so that it's very important for both 8 marks as well as 2 marks, very short answer questions. See the reaction: oxidation of HCl by atmospheric oxygen in the presence of cupric chloride at 723 Kelvin gives chlorine. Oxidation of hydrochloric acid with atmospheric oxygen, 4HCl plus O2. Just in the above reaction what I said, Wherever you find hydrogen and oxygen in different reactants, then you just get the water molecules. So 2 oxygens are there, so 2 H2O will be formed. Otherwise 4 hydrogens are there, half of the number of hydrogen atoms, and you will get the number of water molecules. That means 4 hydrogens, you get 2 water molecules. So that means hydrogens and oxygens completely over, consumed in the reaction. Next, what is left? 4 chlorine atoms are left. Chlorine is a diatomic molecule. Whenever chlorine you find, chlorine will be in a Cl2 form, Cl2. Okay. Here 4 hydrogens, 4 chlorines are left now. So 4 chlorines will be in the form of 2Cl2. So 2Cl2. We will get a chlorine molecule, right? This is the preparation method. Now we'll see how chlorine reacts with different chemicals or chemical reagents. The first one, how chlorine reacts with cold dilute cold and dilute NaOH. So first, chlorine reacts with cold dilute NaOH, gives a mixture of sodium chloride and sodium hypochlorite. This is sodium chloride, this one is a sodium hypochlorite. It is written as NaOCl. Sometimes you can also write NaClO, no problem. And let's see how the products are formed. Here the reaction is 2NaOH reacts with Cl2. You forget about the products. I will explain how the products will form. You just concentrate on reactants. 2 moles of NaOH and chlorine, 1 mole of chlorine. You do one thing, out of 2 moles of NaOH, and you take 1 Na and 1 Cl, 1 Na and 1 Cl, you get NaCl, and still 1 more Na and 1 more Cl left, right? 1 Na and 1 Cl left, that Na and Cl, Na and Cl, and how many oxygens are there here? This 2 is common for all, 2 oxygens are there. You take half of the oxygens, means you take 1 oxygen. There are 2 oxygens, you take only 1 oxygen. That oxygen is this, right? That means 1 Na, 1 Cl and 1 oxygen, that gives NaOCl, right? Understood? So first one, 1 Na, 1 Cl gives NaCl, and remaining Na and remaining Cl along with 1 oxygen here, you will get NaOCl. What is left? And here 2 hydrogens are there, 2 hydrogens are there, and out of 2 oxygens, 1 oxygen is already consumed in the form of sodium hypochlorite, NaOCl. That means 2 hydrogens, 1 oxygen left, that gives H2O, water molecule. Got the point? So that's it, very simple. Okay, and if you can understand this reaction, the next reaction is very easy, super easy. See here, how chlorine reacts with a hot concentrated sodium hydroxide. Chlorine reacts with a hot concentrated NaOH, gives a mixture of sodium chloride and sodium chlorate. Sodium chloride NaCl, sodium chlorate NaClO3. See here, and how to get these reactants and how to compare these two first and second reactions. Here in a cold dilute NaOH, we have used 2 moles of NaOH and 1 mole of chlorine, right? Here you just multiply these 2 reactants with 3, so that you will get the reactants in the second reaction. So 3 2s are 6 NaOH, and 3 into 1, 3 Cl2, that's it. So this is how you can remember the reactants, that is the number of moles of reactants. After remembering number of moles of reactants, now we have to know how the products will be formed. In the previous one what I said, the same process will follow here also. Here 6 Na and 3 to the 6 chlorines are there. You do one thing, take 5 Na and 5 Cl, then you get 5 NaCl. Out of 6 Na and 6 Cl atoms, and you have taken 5 Na and 5 Cl, you got 5 NaCl. And how many sodium and chlorines are left? 1 Na, 1 Cl left. So 1 Na, 1 Cl. And in the previous reaction I said, here there are 2 oxygen atoms, 2 is common for all, 2 oxygen atoms, and you take half of that. Half means 1 oxygen we have combined with NaCl. Similarly, here how many oxygens are there? Here 6. 6 is common for all. 6 oxygens are there. You take half of that. Half of 6 means 3. So NaClO3. That's it. So 5 Na, 5 Cl, 5 NaCl, and remaining Na and Cl, NaCl, and half of the oxygen atoms, that is equal to 3. So NaClO3. And next final step is how many hydrogens are left? 6 hydrogens are left, and oxygens, 3 oxygens out of 6 oxygens, 3 oxygens already consumed here, 3 more oxygens left. So 6 hydrogens and 3 oxygens always we get and 3H2O. That's all, very simple. And these two reactions are very important, and these two reactions also be asked in a industrial process, as well as it may also be asked in a this laboratory process, right? I hope you understood these two important reactions. And next let's discuss how chlorine reacts with excess of ammonia. Why we are calling excess of ammonia? Just see the reaction here. 8 moles of ammonia, 3 moles of chlorine. That means ammonia is an excess 8 moles and chlorine is only 3 moles. That's why we are calling this reaction as reaction of chlorine with excess of ammonia. Chlorine with excess of ammonia gives nitrogen and ammonium chloride. We'll see how the reaction takes place. So reaction is very simple. You do one thing. So 8NH3 now. Out of 8, here 8 nitrogens are there. You take 2 nitrogens out. That becomes N2, nitrogen gas. Out of 8 nitrogens, 2 nitrogens you have taken out, and it becomes N2, nitrogen gas. And next thing is you combine all, remaining all. So remaining how many nitrogens are there? 6 nitrogens are there here. Chlorines, 3 2s are 6. 6 chlorines are there. And hydrogens, 8 3s are 24 hydrogens. So here 6 is common, no? So 6 nitrogens, 6 chlorines, you take 6 common, 6 N and Cl, and hydrogens 24 are there, so 6 4s are 24. So 24 hydrogens. That's it. So nitrogen molecule and 6 NH4Cl. This is ammonium chloride. Next one, with excess of chlorine. That means ammonia with excess of chlorine. A small spelling mistake is there, so don't worry. So excess of chlorine. The excess of chlorine reacts with ammonia, gives nitrogen trichloride. So you have written NH3 ammonia, 3 moles of chlorine. So you compare these two reactions to not confuse with the number of moles. There is no change in the number of moles of chlorine, the previous reaction and this reaction, 3Cl2, 3Cl2, no change. Only change is here ammonia 8 moles, but here ammonia 1 mole. That means the number of moles of ammonia decreased. That's why, but chlorine is the same. So now here chlorine is excess because ammonia 1 mole, chlorine 3 moles. So chlorine is excess. You do one thing, here 3 hydrogens are there, no? You replace all these 3 hydrogens with 3 chlorines. That means hydrogens and chlorines are interchanged like that. For example, out of 3 hydrogens you substitute 3 chlorines, it becomes NCl3. And how many chlorines left here? Here already 3 chlorines over, so 3 more chlorines left. So and here from here 3 hydrogens will come now. These 3 hydrogens and 3 chlorines combine together to give 3 HCl. That's it. Next, reaction of chlorine with acidified ferrous sulfate. Chlorine oxidizes ferrous sulfate to ferric sulfate. Chlorine oxidizes ferrous sulfate to ferric sulfate. You should know what is ferrous sulfate and ferric sulfate. Do you know the formula of ferrous sulfate and ferric sulfate? Ferrous sulfate is FeSO4. This is the formula of ferrous sulfate, and ferric sulfate is Fe2SO4 taken thrice. This is the formula of ferric sulfate. Now see, ferrous sulfate, this is acidified ferrous sulfate, acidified ferrous sulfate. Why we are calling it as acidified? It is added with the concentrated sulfuric acid H2SO4, 2FeSO4 plus H2SO4 plus Cl2. That means acidified ferrous sulfate reacts with chlorine. And how the product will be formed we will see. And you do one thing, how many ferrous and means iron atoms are there? 2. How many SO4 atom species are there? 2. This 2 is common for both. So 2 iron atoms and 2 moles of sulfate SO4, and here 1 sulfate SO4, one more sulfate is there. That means total 2 Fe's and 2 SO4 groups. So 3 FeSO4 groups. So Fe2 SO4 taken thrice. Here 2 Fe and SO4's 2 and here 1 3, total SO4 taken thrice. Fe2 SO4 taken thrice. This is called ferric sulfate. Ferrous sulfate converted to ferric sulfate. And what left? Here 2 hydrogens left and here 2 chlorines left. So both combined together gives 2 HCl. 2 can be taken common, 2 HCl. That's all, very simple. Chlorine oxidizes ferrous sulfate to ferric sulfate. Next, reaction of chlorine with sodium thiosulfate. This is called sodium thiosulfate. I think you know sodium sulfate formula, Na2SO4. This is called sodium sulfate. In sodium sulfate, if you decrease one oxygen and increase one sulfur, then what happens? Na2 and decrease one oxygen, then it becomes O3, and now increase one sulfur, that becomes S2. Okay, that means one oxygen is replaced by sulfur. This is called sodium thiosulfate. Sodium thiosulfate. Difference between sodium sulfate and sodium thiosulfate is here in sodium thiosulfate, one oxygen will be replaced by one sulfur. Such compounds are called thio compounds, right? Okay, now come to the point. And here sodium thiosulfate plus H2O. Sodium thiosulfate is a salt and it is dissolved in water. We will get a solution, sodium thiosulfate solution, and through which chlorine gas is passed. When we pass chlorine gas, and there will be reaction between these two. Here what happens? You do one thing very simple, as we have done in the previous one. 2 hydrogens, 2 chlorines gives 2 HCl. Similarly, here also 2 hydrogens, 2 chlorines gives 2 HCl. Over. And next what you need to do, you take this oxygen and add here and remove one sulfur. Just a few seconds back I told you sodium thiosulfate means one in the place of one oxygen, one sulfur is substituted. Now you do the process reverse. That means you add one oxygen, substitute one oxygen and remove one sulfur. Then it becomes Na2SO4. We have reduced one sulfur and the sulfur we have written at the end. This is sulfur. That means chlorine on reaction with sodium thiosulfate precipitates sulfur. That means it gives sulfur out. Next, reaction of chlorine with hydrogen sulfide, H2S, hydrogen sulfide. This is the gas you might have studied in general knowledge questions and all, and a gas which gives a rotten egg smell. So very bad smell, okay, hydrogen sulfide, but it's at very good chemical compound, and it has many applications in chemistry, right? Chlorine on reaction with hydrogen sulfide precipitates sulfur. The previous reaction also, and chlorine on reaction with sodium thiosulfate precipitates sulfur. Here also very similar. H2S, hydrogen sulfide, plus chlorine, Cl2. You do the same, H2 and Cl2 combine to give 2 HCl over. What's left here? Yes, sulfur is left. The sulfur we have written separately. That's it. Next, final, Slakel lime. Reaction with Slakel lime. Calcium hydroxide, CaOH taken twice plus Cl2 gives. You do one thing here, OH taken twice. OH taken twice means here there will be see OH, two OH groups. Two OH groups means two hydrogens and two oxygens, and out of that two hydrogens and one oxygen if you take, that becomes H2O, right? H2O. And what is left out of two oxygens and two hydrogens? We have taken two hydrogens and one oxygen and it has become H2O. H2O can be written separately, and what's left here? One oxygen is left. That oxygen combines with this Ca, then it becomes CaO, and here Cl2 is there, CaO and Cl2. I hope you understood this. If not, see here, once again I will write on this screen. I am writing here CaOH taken twice plus Cl2 gives, you take this calcium and one oxygen, then it becomes CaO, and take this Cl2, CaO, Cl2 plus, and what left here? Two hydrogens left and one oxygen left. One oxygen we have already used here, one more oxygen left here, taken twice is there, no, that means two oxygens, two hydrogens, that those two hydrogens and that oxygen combines gives water molecule H2O. This is called bleaching powder. CaOCl2 is called bleaching powder. Its chemical name is calcium oxychloride, calcium oxychloride or bleaching powder. That's it. So these are the different chemical properties of chlorine, and any one of these chemical properties may also ask for 2 marks, very short answer questions. So don't forget, and it's a very important question. Okay, and you learn how chlorine is prepared by Nelson cell method, and chemical properties, you go through all these chemical properties. Join our WhatsApp group and you will get regular updates of chemistry videos, and these videos are prepared by me, and particularly this series of videos prepared by with the help of the material created by my friend Santosh Kumar Reddy. Thank you for watching, and we will meet in the next video.